Hello, everyone. Today, let's take a look at this question from isentropic flow with different Mach numbers of flows. And let's find T1 over T2, P2 over P1, C2 over C1, and V2 over V1. Let's start by putting out all the parameters. Our given M1, 0.2, M2, 0.8, and don't let us forget gamma 1, 0.2, gamma 2 is 1.2, and gamma equals 1.4. Now let's start by finding the equation for the stagnant entity from this particular flow, from a reservoir to the throat and down to the outlet. Now, using the stagnation equation, we state that TO, that is the temperature at stagnation, to T1 equals 1 plus gamma 1 M1 squared. And this will become T naught over T2 equals 1 plus gamma 1 M2 squared, which eventually become T2 over T1 equals 1 plus gamma 1 M1 squared over 1 plus gamma 1 M2 squared. And if that should be the case, we can establish our stagnation equation to be T2, T1 using this particular equation. Be 1 plus 0.2, 0.2 squared over 1 plus 0.2, 0.8 squared. So therefore, our T2 over T1 equals 0.8936. Calculated. Likewise, we can find the isentropic equation. We state that P2 over P1 equals T2 over T1 gamma minus 1. And this eventually becomes 1 plus gamma 1 M1 squared over 1 plus gamma 1 M2 squared, all into bracket gamma minus 1. And if that should be the case, you can slot in all the values, parameters. So therefore, our P2 over P1 becomes 1 plus 0.2 squared over 1 plus 0.8 squared, all to the power of 1.4 minus 1. Our P2 over P1 equals 0.6746. Likewise, we can use the sound equation to find the C2 over C1. And this equation states that C2 over C1, that is the sound speed, equals gamma Rg T2 over gamma Rg T1. And this becomes T2 over T1 raised to, this eventually becomes 1 plus gamma 1 m1 squared over 1 plus gamma 1 m2 squared. And from here, our C2 over C1 becomes 1 plus 0.2 squared over 1 plus 0.2 0.8 squared. Our C2 over C1 becomes 0.9453. Now, by using the Mach equation to find the V2 over V1, V2 over V1 equals M2 C2 over M1 C1, which eventually become M2 M1 1 plus gamma 1 M1 squared 1 plus gamma 1 M2 squared. And if that should be the case, we can slot in all the values. V2 over V1 becomes 0.8 or 0.2. 1 plus 0.2 0.2 squared over 1 plus 0.2, 0.8 squared. So therefore, our V2 over V1 becomes 3.89. Now to find the ratio of the density, that is rho 2 over rho 1, you can use the state equation. Which state that rho 2 over rho 1 equals P2 over RG T2 over P1 over RG T1, and this eventually becomes P2 T1 over P1 T2. And don't let us forget from the previous equation that P2 over P1 equals 0.6746. Then T1 over T2 equals 1 over 0.8936. So the ratio of the density P2 over P1 equals 0.76. Thank you for staying tuned.